Hey folks, first day of statistics here, so I wanted to make a little video for those of you that missed the Zoom call. Today we learned two things. We learned how to put data into something called a dot plot. Now when I say data, I just mean a list of numbers, okay? So we learned how to make turn a list of numbers into a dot plot. That is useful because pictures are way better for our brains than just trying to look at a bunch of numbers. And then the second thing we learned was how to describe the data in a dot plot. So that's what I'm going to tell you guys right now in the next 5 minutes or so. So first thing, making a dot plot. Well, here's what a dot plot looks like. What I have here is a list of kids, and we asked them one question: how much sleep you get last night? So one kid said they only got 2 hours. One kid said they got 5 hours. 4 kids said they got 6 hours. 3 kids said they got 7, etc. So that's a dot plot. It's a pretty nice, easy way to get a list of numbers and just make them into a picture. Now, I could also ask, and this happens all the time, but people will say, well, okay, great, but can you just describe the data? Like, what is it telling you? What do you notice? So mathematicians have come up with a nice, easy 4-sentence way to describe most data. And that is, well, here, there's a little acronym that we can use, all right? So you can just think of it like this. S-O-C-S, it spells SOCS, kind of. This first S is tell me the shape of the data. So when I'm looking at this, the shape of the data here, well, if you kind of just sort of blur your eyes, can you tell that it basically is a tail over here, followed by a big center, a hump, and then a tail over here? That is a really common shape. You'll see that all the time in data. Like if you were looking at the heights of human beings, like if you look at guys, most guys, their average height is like 5'9", and then you have some like 7'2" tall people here, but not many. And you have some 4'8" people here, but not many. Most of us are right in the middle, so it's a really common shape. It's called, that shape, approximately normal. Approximately normal. It's not perfectly normal because usually the tails aren't perfectly even. So we say it's approximately normal. So when I am describing this data, my first sentence is going to be about the shape. I'm just going to say the shape of the data is approximately, and I'm going to abbreviate there, approximately normal. Great. So that's the first letter. The O here stands for outliers. Are there any outliers? Well, you might be able to guess what an outlier is. It's basically some data that's far away, that lies out from all the rest of them. So when we're looking at this data here, the one that sticks out to me is that 2. That 2 is an outlier. It's far away from the rest of the data. So that's going to be my second sentence. I'm going to tell people, hey, there is an outlier at 2. Great. So we have shape and we have outliers. Now the next one is center. So the C stands for the center of the data. So what's the central value of this data? Well, you guys, do you remember the phrase mean, median, mode? Those are all ways to get the center of the data. I'm going to focus right now on the mean, and that just means the average. So let me tell you, there is one way to get the average exactly, and that is add up all these numbers, 2 plus 5 plus 6 plus 6 plus 6 plus 6 plus 7 plus 7 plus 7, etc. Add them all up, and then divide by how many there are. That'll totally do it for you. I am also going to tell you this. Usually you're dealing with this, well, no, I'll just say this. There's an easy way to just approximate that mean without having to do all that arithmetic. And here's how you do it. Imagine that this x-axis here is just a really strong but very lightweight platform, okay? And then imagine each of these dots is a brick. Then you can tell, like, if this were like a seesaw, if I put the fulcrum right here, can you tell if this would the platform balance? No way. There's way more bricks over here, and it would so the seesaw would just topple over, right? Or if I put my balancing point right here, can you tell it would fall over the other way because there's way more bricks over on this side than there are on that side? So you just got to figure out, where is this balancing point? Well, for me, I mean, this 2 is going to be have a lot of influence just because it's so far out. Just like in a normal teeter-totter, that works too, right? The farther you are from the center, the more influence you'll have. I don't know. I'm thinking like maybe right somewhere between 7 and 8. I would probably have a balancing point where the bricks on this side would balance the bricks on that side. So I'm going to say my center, I'm going to say the mean of the data, because that's my center that I'm using. The mean of the data is, and I'm going to say about, because I didn't actually figure it out, I'm just eyeballing it, is about 7.5. Okay? So that's shape, outlier, and center. The last one is the spread of the data. And for our purposes, I just want right now the lowest to the highest, okay? So do you guys agree that we go between 2 and 11? Then that's all I'm going to write. The spread of the data goes from 2 to 11. Bam. Done. That's it. That's all I need from you at this level that we're at right now. If I ask you to make a plot of the data, make a dot plot. You don't need this blue line. I just drew that in there for so that you guys can see the shape of the data a little more easily. And if I ask you to describe the data, wear your socks, okay? S.O.C.S. Shape, outlier, center, spread. Right now, the only shape you know is the hump in the middle, tails on either side. That's approximately normal. Are there any outliers? The center, the only way that you guys know how to do that right now is to find the balance point, which will tell you about what the mean is. And then the spread is just what's our lowest to what's our highest, okay? Shazam, you should be able to do the homework now with this knowledge. See ya.